Okay, in these final challenges, we're going to look at these really tricky questions. This is for if you're aiming for the very top grades here. We're going to be thinking about how you can make the bases match in a question. So you'll see here that these numbers all look pretty different to each other, but they all have something in common. These numbers all look pretty different to each other, but they also have something in common. The thing that they all have in common is that you could write them with the same base. So what I mean by that is I could write all of these ones here as base 2, like this, 2 to the power of something, and all of these ones here could be 3 to the power of something. So this is like a 2 to the power of 1 and a 2 squared. This is a 3 to the power of 1 and a 3 squared. Well, the 8 and the 27, 8 could be written as 2 cubed, and 27 could be written as 3 cubed. The square root of 2 could be written as 2 to the half, and the square root of 3 could be written as 3 to the half. And a half could be written as 2 to the power of minus 1, and a third could be written as 3 to the power of minus 1. So what they really want you to do in these questions is look at the sort of set of numbers that you have, like these blue ones I have here and here, and think, how could I make that look like the same base to do some other things? So it says here, work out n if 3 to the power of n is equal to 1 over 9. Well, I'm going to keep the 3 to the power of n. Now 1 over 9 is 1 over 3 squared, and 1 over 3 squared is 3 to the minus 2. So at this stage, you can literally just compare them, and you can say when you compare these things that n must be the same as minus 2 for this to be true. So n is minus 2. This one is definitely a bit trickier because we want to write these as powers of 2. So I'm going to keep my 2 to the power of n. Well, 4 is 2 squared, and it's multiplying by the square root of 2, which is 2 to the power of a half. So we're going to then add those powers because these two things are being multiplied. Remember, you add the powers. And 2 plus a half, you can either say that it's 2.5 or you could say that it's 5 over 2. So we get 2 to the power of 5 over 2. That means, just by comparison, that n must be equal to 5 over 2. This last one is also trickier. So I'm going to say that this could be rewritten as 1 over 3 to the half. So 3 to the n is the same as, well, that would be 3 to the power of minus a half because it's down in the denominator, so we can say that it's actually had a negative power, meaning when you compare the powers that n is minus a half. Okay, we have got 3 exam style problems that use this kind of skill, and you can see they've got a little extra layer of trickiness. So then again, this one is only 2 marks. I think it's pretty harsh. It says, given that this, and this are all true, find the value of a, b, and c. So let's have a look at that first one. We have 2 to the power of a equals 1 over 8. Well, 8 we know is 2 cubed. So if I keep going with that one, I could say that 1 over 2 cubed is 2 to the power of minus 3. And just by comparison, that means that a is equal to minus 3. Now for the second one, I have 2 to the power of b equals 4 root 2. So 4 root 2, that's 2 squared times 2 to the half. This is very similar to the one we just did. You add those powers, and that would be 2 to the power of 5 over 2, or 2 to the power of 2.5. I don't mind if you want to do it as a decimal or a fraction. I probably prefer the fraction, but I'll do one as a decimal just for a change. So that means that b is equal to 2.5. And then our last one, 2 to the power of c is equal to 2 over root 2. Well, that's 2 to the power of 1 divided by 2 to the power of a half. And the subtraction law means you do 1 take away a half, and 1 take away a half is just a half. 2 divided by root 2 is 2 to the power of a half. Now by comparing these things, we can see that c must be equal to a half, or because I've done the other one in decimals, I'm going to do this in decimals too. So it wants us to work out the value of a plus b plus c. So that is a plus b plus c. Okay, well, minus 3 plus 2.5 plus 0.5. The 2.5 and 0.5 makes a 3, so the answer is 0. Okay, next one. You might want to have a go at this one yourself. Again, it's only 2 marks. It wants us to write this thing as a power of 2. In other words, 2 with some power that we've got. Okay, so we have 4 to the 2x over 8 to the x minus 3. Well, 4 is 2 squared. So I'm going to do 2 squared, and that's going to be raised to the power of 2x. And we know that 8 is 2 cubed, and that's going to be raised to the power of x minus 3. Now we just need to think carefully about the multiplication, because it's the brackets, you can multiply them. So that would be 2 to the power of 4x over, now we've got 3 being multiplied by x minus 3. Really, that's 3 being multiplied by x minus 3 in brackets. Of course, you could also write it as 2 to the power of x minus 3 cubed. Okay, it doesn't really matter which way around these things go because they're multiplying. So 3, the power will be 3 times x minus 3. So it's going to be 2 to the power of 3x minus 9. Now we need to think of what's going to happen. We're doing a division, so we will subtract the powers at this stage because we're doing a division. So it is going to be, I might want to do it somewhere on my page, 4x minus 3x minus 9. Now because you're subtracting, you need to make sure that you're subtracting the overall thing because it's going to become 4x minus 3x. But when you subtract a negative 9, you're actually adding on a positive 9. That's the thing that people usually make a mistake of here because you're subtracting a negative. When you subtract a negative, it is a plus. When you do things like that, it becomes plus, doesn't it? So it is going to be 2 to the power of 4x minus 3x is just x, so it is x plus 9. So our answer is 2 to the power of x plus 9. That has been written as a power of 2. And now our last exam style problem says, given that 27 to the half equals 3 to the x minus 1 times 9 to the third, I guess it should say find x, which I haven't written down, but hey, I've done it now. 3 marks. So again, 27, 3 and 9, the theme is that they all look like they're to do with powers of 3, so I think that's what we should do. 27 is 3 cubed, and that's going to be to the power of a half. We have 3 to the power of x minus 1. Now you can't just add these powers straight away because they have a different base, so we need to switch the 9 to 3 squared. That's 3 squared to the third. Now I'm going to tidy this up by multiplying these powers together, so that's 3 to the power of 3 times a half is 3 over 2. And then I'm going to be 3 to the x minus 1 multiplied by 3 to the power of 2 thirds. So this is 3 to the power of 3 over 2. And then with these bits, you're going to be taking this power and adding them together because you're multiplying. So that's x minus 1 plus 2 thirds. Well, minus 1 plus 2 thirds, that's actually minus 3 over 3 plus 2 over 3. Oh, it's just x minus a third. You probably could just say that minus the 1 plus 2 thirds, it's going to be definitely minus a third. So when we add these bits together, we get 3 to the power of x minus a third. Now at this stage, we can say that because they've got the same base of 3, we can actually just compare the green parts that I'm highlighting here together and say that they must be equal to each other for this to be true. So that must mean that 3 over 2 is equal to x minus a third. So to solve this equation, I'm just going to do 3 over 2 plus 1 third, whatever method you use for adding fractions, but it's going to be 9 plus 2 over 6 is equal to x. So that means, just finishing this off, that x is equal to 11 sixths. A very, very challenging question that requires a number of different skills there. This is an interesting bit though. Once you get to that stage, you can just compare them and say the powers must be equal because the bases are equal and we've combined them into one single base, unlike this part here where there were 2 separate ones. And that's the end. Oh no, it's not the end. I've got one more question. I think I might actually pause this video here. No, let's push on. Let's just do these last exam style problems that we've got. So here it says, given that a equals 3 to the x and b equals 3 to the y, express in terms of a and or b, these ones that we have. So 3 to the y plus 2. Well, because these powers have been added, I think it's come from something that has multiplied. So I think it's going to be 3 to the y multiplied by 3 squared. Okay, so that's going to help me use this. I'm going to try and take this thing and write it in this language. It looks like I can now replace this with a b. So this is a b multiplied by 3 squared, which is 9. So I could just write this one as 9b. So we're going to be using some of the other index laws in reverse here. We're going to do 3 to the power of x, and it's going to be multiplied by 3 to the power of y. 3 to the power of x is a, and 3 to the power of y is b, so it's just a times b, or ab. Now this one is a little bit more tricky because of the fact this has a base of 9 and this has a base of 3. So I'm going to replace the 9 with a 3 squared, and that's all to the power of x minus y. So thinking carefully here, these are going to multiply, not just these two, but the whole thing will multiply by 2. So it's 3 to the power of 2x minus 2y. Well, let's think about this as a different kind of calculation. This is going to be 3 to the power of 2x divided by 3 to the power of 2y, because remember, when you're dividing, it becomes a subtract. So we're doing a lot of log laws in reverse. This is going to be 3 to the power of x to the power of 2 and 3 to the power of y to the power of 2, because you multiply the x and the 2 to get 2x, and you multiply the y and the 2 to get 2y. So we're now using the bracket law in reverse. We've said that 3 to the power of x is a, so you get a squared, and 3 to the power of y is b, so you get b squared. Probably the most challenging question that we've done on this whole thing so far. And the last one, well done if you're still with me. It says, given that 7 to the power of minus n equals 0.4, find the value of 7 to the power of 2n. Actually, this one's not that tricky. So 7 to the power of minus n equals 0.4. Well, 0.4 we know is a fraction, right? It's 2/5. So I'm trying to find out what 7 to the power of 2n is. Well, let's take the reciprocal of both sides. Let's deal with this negative that's in front of the n, and let's just say that 7 to the power of n is 5/2. We've just taken the reciprocal. And now I want to make it 7 to the power of 2n. Well, to get it as a 7 to the power of 2n, I'm multiplying it by 2. In other words, I'm squaring it, because the n and the 2 will multiply to get 2n. So I better do the same thing on the other side. So that's 5/2 squared. So 7 to the power of 2n is 5 squared over 2 squared, which is 25/4. So well done if you've caught up, if you've been able to keep up with all of these questions. I think they've been really quite tricky, and this has been quite a long video because I've done this matching the bases alongside some exam questions as well. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. This is the end of the playlist, but head to my channel's homepage to see what else I might be able to help you with. And as always, wishing you the very best for all your studies.